नमस्कार दोस्तों, today's our topic is solution of solids in liquids. So first of all, let us take a container in which we have liquid. Now in this liquid we add solid. So means one is solute, solid is solute, and liquid is solvent, and that leads to the formation of solution. Okay, what happened in the beginning? Solid, if it has similar chemical structure and polarity, then this solid start dissolving in liquid. When this solid dissolves in liquid, then at the beginning the rate of dissolution is higher than the rate of crystallization. Now what is this rate of crystallization? When this solid start dissolving, the particle becomes small, and these small particles, when they are more in number, they start colliding with each other, start sticking to each other, and that's why that is called crystallization. But in the beginning that collisions are very less, that's why dissolution rate is greater than crystallization rate. But as the time progresses, a stage is reached when rate of dissolution is equal to rate of crystallization, and that means it is at equilibrium. Now at this stage, what happened? Amount of the solid in the liquid is maximum. If more solid is added in it, then what would happen? That solid starts dissolving in it, but equivalent amount of solid comes out, separate out. That called means crystallization rate becomes greater, and that's why at that stage, what is the amount of solid? At this stage, equilibrium, amount of solid in gram that is dissolved in 100 gram of solvent to form saturated solution. At this point, when dissolution rate is equal to crystallization rate, this is called saturation point. Before that, solution is unsaturated because more solute can be dissolved. At this stage, maximum amount of solute is dissolved. More solute cannot be dissolved. And if solute is more than the dissolved amount, that is called supersaturated solution, and that is unstable stage. A small change in temperature or pressure may lead to crystallization. Okay, so maximum amount of solute, we can write maximum amount of solute in gram that is dissolved in 100 gram of solvent to form saturated solution at a particular temperature. Is called solubility. So this is a standard definition of solubility. In terms of molarity, solubility is equal to maximum molarity, and it can be expressed in mole fraction even, right? So what happened at the start of the dissolution process? When solid starts adding, we are adding solid in liquid, rate of dissolution is greater than rate of crystallization. As the time progresses, a stage is reached when dissolution rate is equal to crystallization rate, and that is called saturation point. At this point of time, the solid dissolved is equal to solid crystallized, means more solid cannot be dissolved. If we add more, let us take example, if we at saturation point we add 5 gram of solute or solid, then this 5 gram gets dissolved, but equivalent amount comes out, means the amount dissolved in this liquid is fixed at that time, and that is called saturation point. And at that saturation point, what is the amount of solid in gram in 100 gram of solvent? That is called solubility. So just note down this part, then we will proceed further. Now, what are the factors affecting the solubility of a solid in a liquid? So there are 3 factors: nature of solute and solvent, then temperature, and least significant is pressure. Pressure has almost no effect on the solubility of a solid in liquid, but anyhow we write all the 3, then we discuss one by one. So first is nature of solute and solvent. Now nature of solute and solvent means the solute and solvent which are chemically similar and have almost same polarity can dissolve easily in each other. Means here one principle prevails, that is like dissolves like. Means polar molecules, polar solids you can say, or ionic solids are more soluble in polar solvents like water. You know, water is a universal solvent. Why? Because ionic solids, all the ionic solids are soluble in water, almost all except 1 or 2. And polar solids, polar molecules or solids or ionic solids are more soluble in polar solvents than in non-polar solvents. Or if we have non-polar molecular solids, they are more soluble in non-polar, or we can say covalent or organic solvents like, name some, like ether, benzene, CCl4, than in polar solvents like water. So this is the nature of solute and solvent. For example, if we talk about NaCl, NaCl is which type of solid? It is ionic solid. It is more soluble in water than in benzene or ether or CCl4. But iodine, iodine is non-polar. It is covalent solid. So it is more soluble in non-polar solvents, or we can say organic solvents like CCl4 than in water, right? So why is it so? Actually, what happened when we add ionic solid in water? Water has very high dielectric constant. Let us discuss solubility of ionic solids in polar solvents. Just note down, then we will discuss in detail the solubility of ionic solids in water. Just note down it. Now let us discuss solubility of NaCl in water, or we can say any ionic solid A, B. So when AB is there, A is positive and B is negative. So let us draw it like this: negative part and positive part. And what about water? It is a polar. What do you mean by polar actually? Which has two poles, negative and positive. Charge are separated. That is called polar molecule. So water is a polar molecule because it has positive end and negative end. So let us draw it like negative and positive. Okay. Now this is the ionic compound. Okay. Cation is attracted towards anion by electrostatic force of attraction, and these forces are very strong. So when these forces are very strong, how do they separate? So what is the mechanism behind it? This positive part attract which part of the solvent? Negative part. So this negative part is attracted by this negative end of the polar solvent, and this negative end is attracted by positive ends of the solvent molecules. So because of this attraction of positive ends of the solvent and these negative ends of solvent, what happened? This positive ion is attracted towards this side, and negative part of the ionic compound, ionic solid, towards other end, opposite end. Therefore, they strongly attract these ends, and that's why they separate out. And when they try to separate out, what happened? Positive end is surrounded by negative ends, and negative end is surrounded by positive ends. And because of this, these ions, negative and positive ions, now freely move in the solution. Because of this, atmosphere of solvent molecules, and then these ions are called hydrated ions. First, these ions which are attracted by electrostatic force of attraction, let us take NaCl solid, they separate into Na plus and Cl negative, and this is known as lattice energy. Energy required to break 1 mole of ionic solid into its gaseous ions is called lattice energy. It is amount of enthalpy required to break 1 mole of ionic solid into its gaseous ions is called lattice energy. So this energy is absorbed actually. This is lattice energy, and when these ions separate out by consuming this energy, these ions are surrounded by solvent molecules, water molecules, and that is called hydration. These ions are hydrated now. These are hydrated ions, and energy is released, and that energy is called hydration enthalpy. So this is the amount of enthalpy released when ions obtained from 1 mole of ionic solid are hydrated, or we can say surrounded by water molecules, and because they are surrounded, this is which type of attraction is this? Ion dipole attraction. They are hydrated by ion dipole attraction. Now, if lattice energy is less than hydration energy, then energy released is more than energy absorbed, and that's why enthalpy of solution for such reaction is negative, means exothermic dissolution is there, and solid is easily dissolved. But if lattice energy is greater than hydration energy, then solid is not dissolved, or we can say enthalpy of solution is positive, and if lattice energy is equal to hydration energy, there is no dissolution, there is no enthalpy of solution. No energy is absorbed or released. In this case, dissolution is exothermic. In this case, dissolution is endothermic. This is the favorable case for the dissolution of the solid in liquid. So that's why ionic solid can dissolve if lattice energy is less than hydration energy. See, when these ions are hydrated, it is like this. By lattice energy, they separate into gaseous ions. By hydration, they change into aqueous ions, right? We can write it pictorially. First draw it. You know what is now lattice energy and what is hydration energy. What is lattice energy? Breaking of ionic solid into gaseous ions, and hydration energy is when these gaseous ions obtained from ionic solid are hydrated by ion dipole attraction. And if lattice energy is less than hydration energy, this is the favorable case for solubility, then solid is soluble in the liquid. Okay, just note down, then we proceed further. Now see, we write NaCl solid. If we write simply, it is dissolved in liquid, it is like this. So first of all, NaCl solid changes into Na positive gas and Cl negative gas, and then it changes into aqueous. This is lattice energy, this one is hydration energy, and this is enthalpy of solution. Here we apply Hess law that enthalpy of solution is equal to lattice energy plus hydration energy. Now, then why not non-polar solid are soluble in polar solvents? Reason is, in non-polar solvents, non-polar solvent, they are weakly attracted towards each other, and polar solvents, there is strong dipole-dipole attraction. So this non-polar solid interaction means, in non-polar solid interaction there is simple van der Waals attraction. Here dipole-dipole attraction. So these dipole-dipole attractions are much stronger. That's why the attraction between the polar molecules are not broken by these non-polar solid molecules. That's why they cannot enter in the polar atmosphere, because this is, let us take, this is solute and this is solvent. So solute solvent interaction is much weaker than solvent interaction. That's why non-polar solids are not soluble in polar solvents. That's why like dissolves like. And non-polar solid is soluble in non-polar solvent because of same type of solute-solute, solvent-solvent, and solute-solvent interaction in case of non-polar solid in non-polar solvents, because of same type of solute-solute, solvent-solvent and solute-solvent interactions. Right? Now let us discuss effect of temperature. So let us discuss the effect of temperature on the solubility of a solid in liquid. So according to List-Hallier's principle, endothermic reactions are favorable at reactions or processes favorable at high temperature. And what about exothermic? Exothermic processes are favorable at low temperature. So if dissolution, enthalpy of solution is negative, means if it is exothermic, then solubility decreases on increasing temperature. Or if enthalpy of solution is positive, means if dissolution is endothermic, then solubility increases on increasing temperature. This is the effect of temperature on the solubility of solid in liquid, and it can be written like Van 't Hoff equation, log C2 by C1 equal to delta H over R 1 upon T1 minus 1 upon T2. This is enthalpy of solution. This is concentration of solute at temperature T2, concentration of solute solution at temperature T1. So this is the relation used to see the quantitative effect of temperature on the solubility of a solid in liquid. Then effect of, this is second factor. Then third is effect of pressure. So as already I had told that there is no significant effect of pressure on the solubility of solid in liquid. Why is it so? Because solid as well as liquid both are almost incompressible. Because they are least compressible, that's why there is no significant effect of pressure on the solubility of solid in liquid, right? But even though if we try to see the effect of pressure, so in case of NaCl, solubility is 26.4 gram of NaCl is dissolved in 100 gram of water at 1 atmosphere pressure. And if we try to increase the pressures to see the effect, then it is, if we increase the pressure up to 500 atmosphere, then it is 27 gram only. That means very little effect of pressure is there on the solubility of solid in liquid. There, even in case of ammonium chloride, if we increase the pressure from 1 atmosphere to 500 atmosphere, increase in solubility is only 5%, right? So we can say there is a very little effect of pressure on the solubility of solid in liquid. So this is all about solubility of a solid in liquid. Do like, subscribe and share my channel. God bless you all. Happy learning.